So you might have found this video in a couple of different ways. So this is part of the playlist involving how to conduct and interpret a simple regression in SPSS. And it's also part of the Chapter 16 lecture notes for my class, Psych 301. So if this is part of the class lecture, this is video 3. This is the second video of how to conduct and interpret the simple regression in SPSS. So if you haven't yet watched that video, do make sure to watch the previous videos first, because they show you how to get this output that I'm going to be using in this example. So I'm going to go ahead and continue with the output that I was using from the previous example, where we interpreted our regression analysis from SPSS. So in this video, I'm going to show you how to use that output to actually graph your own line representing the relationship between your variables in your regression analysis. So every equation for a simple linear regression is going to be represented by this general format where B and A are going to be values that we're going to get from our output in SPSS. So this is the general structure for our linear regression equation, and we can get these values for B is going to be actually in that coefficients box in your SPSS output. So you'll see next to the variable that was your predictor, so the variable, your X variable that you were using to predict your Y variable, it should show up in this coefficients box on its own line. So in this example, I was using quiz 1 scores to predict quiz 2 scores. So if you follow along that row, you'll see underneath where it says unstandardized coefficients, underneath the B, that is going to be your value for your slope. So the B, the slope, in this example is going to be 0.838. And we can just keep that with 3 numbers after the decimal point. The main thing we're using this equation for is just to graph our data. So we can go ahead and use that whole value. So that's our value for B. And our value for A is going to be here. And I know this is confusing because it's underneath the B column, but this is actually our value for A. So in the row that should be the top row always, it should say constant. So in that constant row, underneath the unstandardized coefficient B, that is actually your value for A, your y-intercept. So that's our value for A. So let's go ahead and put those two values into our equation solving for y. So this is our general equation that we're going to use to actually graph the relationship between our X, in this case quiz 1 score, and our Y, in this case it would be quiz 2 scores. This is going to be the line that is going to represent the relationship between those two variables. So let's talk about how to actually graph the line. So we're going to take that equation that we just found using the SPSS output, and we have to manually create our own graph. And the reason for that is anything that we can get from SPSS, it's never going to be in the format that we want. So it's easier to just take that equation and then use another program to graph your own line. So let's talk about what we're going to graph first. So in order to figure out the 2 different data points that we're going to need to create a line, the first thing that we want to start off with is we want to figure out what our lowest possible value for X was. So this is dependent on what your study is and what your X value is, whatever your value is that you're trying to use to predict the outcome, Y. So in this case, I was using our quiz 1 scores to predict quiz 2 scores. So in this case, the X value is going to be our quiz 1 scores. So we want to identify what the lowest possible value was for that variable. This quiz was scored from 0 to 10 points. So the lowest possible value that anybody could have for quiz 1 is going to be 0. So we're going to use that 0 as our lowest possible value for X. And again, your lowest possible value for X might be different because it depends on whatever your x variable was and what the scale of measurement was for your x variable. So my x variable, it was the lowest possible value was 0. So I'm going to take this equation that we just established, and I'm just going to plug in that value of 0 into this equation. So instead, in place of where you see the x in our original equation, we're just going to plug in the lowest possible value of x into this equation. So again, my lowest possible quiz 1 score would be 0. So this indicates that we're multiplying that 0.838. We're multiplying that by this x value of 0. So those two get multiplied first based on order of operations, and then we're going to add that y-intercept to it. And so when you work out that equation, that should leave you with the value of 3.243. So that gives us the data point of when our x is 0. So again, we had plugged that into the equation here. So our lowest possible x was 0. So when x is 0, then we predict that the y, so the y hat, the predicted value of y when our x was 0 is going to be 3.243. So we're going to use those data points later to actually graph our regression line. So in order to form a line, though, we actually need 2 different data points. So this is just one data point, so we need a second data point in order to graph the line. So let's talk about how we get our second data point. So the second data point, really you can use any value, but I think the best way to go about graphing your line is to plug in your value. So just like we did in the last one, instead of using the lowest possible value for x, we're now going to use the highest possible value for x. And go ahead and plug that highest possible value for x into our equation to get another data point. So after that, we're going to connect those 2 data points, and I'll show you how to do that in a second. But let's take our equation again that we already established. So this was our equation that we were using to predict our y from the x. So again, all we're going to do here is just plug in a value for this x here. So in this case, we're using the highest possible value. As I mentioned in the last slide, that was 10 for this example. So we're going to take 10 and just plug the number 10 into this equation. So again, with order of operations, do make sure to multiply this by that first and then do your addition. So after you work out that equation, you should get the predicted value for y is 11.623. You might notice that this is higher than the highest possible score on the quiz 2. So the highest possible score is 10, and this is higher than that, and that's okay. So remember that this is just a prediction. So the prediction, it should make a little bit of sense, but it could be slightly outside of the boundaries that are possible. So that's not too far off from the highest possible value of 10, so it's okay. So that's going to be our predicted value of y is 11.623. And that was using that x value of 10 that we plugged into the equation. So this leaves us with the data point with that x highest value, which was 10, and then the predicted value of y when we had an x of 10 was going to be 11.623. So we're going to take this data point, and we'll also take the data point from the last slide, and we're going to use those two to create our graph with this best fitting line. So here's an example, and this isn't exactly in APA style, just mainly because of this. So make sure to look up APA style as it relates to titling your graph. But this gives you the general idea of what you would want your graph to look like in APA style, where we have our x value, our x variable is down here on the x-axis. So in this example, we are using quiz 1 scores to predict our quiz 2 scores. And so technically this would be the predicted value for quiz 2 scores. And so we're just graphing those 2 data points that we just established. So the first data point we established used an x of 0, and it identified that data point to be 3.243, I believe it was. So we find the x of 0 and then that 3.243, and we put our dot there. And then we also take our x value, so our highest value of x that we used was 10, and then we found that predicted value of y to be 11 point something. So we're going to graph that data point, and then we just connected those two data points with a line, and that represents your line of best fit. So that is your regression line. And again, that's just a line that's best explaining your data set. It's not representing any of your actual data from your sample, but it is the line that best explains the relationship that you found between these two variables in your data set. So if we were to take our actual data and then put it onto this graph, you'll see that these were each of our data, well, the quiz 1 score and the quiz 2 score for each of our people in our data set. And you'll notice that when we graph each of these two values, so when we graph somebody's quiz 1 and quiz 2 score and put it onto this graph here, we'll see that all of those data points, they are fairly close to that regression line. This is why we had a significant regression, is because this line is predicting pretty well our actual data. So our data points are falling pretty close to that line. It's a significant regression, and when we do have a significant regression, the best way to represent our data would be to graph that regression line. So that is the process of how you can do that. And you can either keep your data points on your graph or just keep it with only the line. Either of those two is acceptable. Probably this way would be the most common way, is just to graph the line and leave out your data points. So that concludes the videos regarding the simple regression analysis with just one predictor for your outcome. Next video is going to cover how to do a multiple regression analysis. So if you have more than one variable that you're using to predict an outcome, you would want to use a multiple regression analysis. So I'm going to show you how to do that in my next video about how to conduct and interpret a multiple regression analysis using SPSS.